Hi, calculus students. This is part B of a video using product rule, quotient rule, and some chain rule. We have just gotten done in the previous video differentiating f of x. And now when we differentiate g of x, we'll use that memory fact for the factor of square root of x. Excuse me there. Okay. All right. So we need to recognize that this red function g is a product of the square root function and a tangent function. And so with the product rule, we know the derivative of a product ends up being a big fat sum. We'll take the derivative of the square root of x first, we leave the trig function alone, and then we add to that the square root of x times the derivative of the trig function. Right. The square root of a product, I should mean the derivative of a product, is a sum of two special products. One term has the derivative of the first factor. The other term has the derivative of the second factor. Okay. So 4 things we need to attend to. First thing, we need the derivative of the square root function. We'll leave the second function alone. And then we need to leave the square root function alone and take the derivative of tangent. Our memory fact, we know the derivative of tangent is secant squared, but we don't leave the input blank. We need to go back and pick up that argument 3x as the angle to which secant squared is applied. Okay. Now this second blue answer is fine. In class I've been putting a check mark when we get to a completed derivative. And in class I've been letting students know that if they're working on a multiple choice type of exam, that they would need to be ready to recognize an answer that's maybe in what we, a more polite form. And I notice this first term has a denominator of 2 square root of x. So just by experience, I know it might be helpful to rename the second term, which can be thought of the square root of x secant squared of 3x all over 1. And by renaming the second term, we'll be able to add the 2 terms together with a common denominator. So an equivalent way of writing line 2 is line 4. Tangent applied to 3x plus 2 square root of x times, I did that wrong, that should be absolute value, times secant squared of 3x. Okay. Again, that would be tangent of 3x plus 2 times the absolute value of x. And maybe I'll revise this because x is going to have to be positive down here in the denominator. We won't put that. I don't need my absolute value symbols there. Okay. All right, moving on to the third example. I had shown you the derivative, the answer to the derivative of r being the square root of this quotient. Okay, and now we want to differentiate. We've got that quotient raised to the 1/2 power originally. So we can think of this as the extended power rule. Extended power rule. Yes, we can bring down the power 1/2, treat it like a coefficient, leave the base alone. We just copy down the base. We'll subtract 1 from the original exponent, and then we've got to multiply by the derivative of the base. Okay, so this is an incomplete answer, but it's a roadmap of how to get to r prime. Okay, so I'm going to label our answer r prime. And I'm going to see that I have a factor of 1/2, that I can simplify my exponent from the extended power rule. And if I look back, or if I pause and do some scratch work, it can be verified that the derivative of this fraction ends up being another fraction where the original denominator is squared. And you can double check this, but there'll be some nice simplification and we get a -7 in the numerator. Okay. Now this is an okay answer. It's okay. But you might want to recognize an answer that would be more tidy for a multiple choice type of exam. A publisher would probably multiply the -7 times the 1/2. She would probably split apart the numerator and the denominator. She would think of the numerator as being raised to the -1/2 and the denominator also being raised to the power of -1/2. And then she'd recognize that there's 2 additional factors of the denominator down here. And so finally, this is just me, I would imagine a publisher would write this as -7/2. She would drop this square root of 2x minus 3 to the denominator, and then she would combine the product of these terms, the product of these factors, by adding those exponents. And 2 is the same thing as 4/2, so if I add the exponent 4/2 and -1/2, I get an exponent of 3/2. Thank you.